Good morning, student. Welcome to today's class. In today's class, we are going to discuss about passive cooling. From uh, in previous classes, we discussed about what the passive heating of our living room. Okay. Now we discuss about how we cooled our room passively. Okay. In passively means we also I told you already that in passive means we cannot use in the operation or passive operation we cannot use any active device like mechanical fan, mechanical instruments. We cannot use fan, mechanical instrument, electrical instrument in passive cooling. Without using that mechanical or electrical or active elements, we can cool our buildings or living room. That is called passive cooling. Okay. And the uh, and in our building there are there are two thermal loads. One is internal load due to people and applies cooling. Okay. Another one is external due to the climate. That means our room is heated or getting hot due to two region. Okay. One is externally by the climate or summer or sun anything, and second one is internally when we switch on our electric bulb and or any, on or running any appliances like TV, fan, etc. They emit little bit of heat. Okay. That heat uh, that heat heated our room also. Okay. And we can cool our living room or building by eliminating these two region. Okay. The first one internally internal what internal thermal rod we can eliminate by using the by using the way of lighting in daylight or the internal lighting of building create an important load. But there have been effort to determine the benefit of diffused daylight replace electrical bulb. That means the internal lighting. Okay. Internal lighting is uh, uh, is uh, is replaced, or internal electrical bulb is replaced by diffused sunlight coming from sun. Okay. In daytime. Okay. And the external uh, uh, the external factor or externally thermal load is removed or take care by using there are three major ways. By using three major ways. One is penetration of direct beam sunlight or removing or minimizing the penetration of direct beam sunlight, and second one is conditioning of heat through wall and roof, and third one is infiltration of outside air. Okay. These three these three ways, or by these three ways we can minimize our external thermal load in our building. Okay. Let's see first minimization of direct beam radiation. That means we can minimize or we can protect our building from the direct radiation of sunlight. Okay. Or direct ray of sun ray. Okay. The shading the enter of direct radiation through window provide a reduction of heat gain into the building. That means in which building or in which window or door, from that door the sun radiate to the building, or sun radiation enter to our building, we can shading them, or we can protect them to not to enter the sun ray. Okay, that that means by shading the entry of direct radiation through windows provide reduction of heat gain. Okay, for that purpose, or for that shading purpose, we use vertical, horizontal and inclined lowers. Okay, vertical, horizontal and inclined lowers, movable screen, deciduous trees and plants. Okay, these are used for the shading of the direct radiation of these windows or door. Okay, and shading against direct radiation is easiest to provide on the south wall. Okay, because in the south wall the sun position is different for winter and summer. Okay, here you can see for summer this is the sun position or peak time of sun position, and for winter this is the peak time of sun position. Okay, due to the position difference, the for providing, or for shading of direct radiation is easy to provide on south wall. Okay, a horizontal projection of uh, appro- appropriate depth will exclude the summer sun. That means a horizontal, this is that means a horizontal projection. Horizontal projection means there is a shade. Okay, in our uh, window, the upper part of the window has a what is called the shading, or uh, or what is calling this means the window, this is our window, and we build a shading of this which protect in rain or in from sunlight. Okay, this is the shading, and this shading this shading or the vertical projection is such in measurement that it didn't allow the light or direct radiation in summer. Okay, but it allow in winter. The direct radiation is allowed in winter, because in winter we want some heat. Okay, but in summer we don't want any heat. Okay, but since we don't allow direct radiation in summer and in winter by using shading. Okay, or by using uh, vertical projection in our south wall window. Okay, next one is conduction of heat through wall and roof. That means a since our roof is nakedly displayed to the sun all of the day. Okay, and also our wall, so this is a high area which is facing to sun, so this is capture a high amount of thermal energy from sun radiation. Okay, yeah, and this can be minimized by using shading, Okay, what is shading? Okay, in shading, okay, sun radiation, the various building elements should be provided adapted shading to minimize the amount of radiation absorbed by the outside surface. The roof is graded required minimize attention seen it receive the maximum radiation. That means in outside surface the roof is most important for shading. Okay, because the roof is a big surface area, has a big surface area, and it is nakedly facing to the sun. Okay, if we what if we textured our wall, okay, side wall, then it provides some shading due to the in due to the formation of, or rough shape of the wall. Okay, here you see this is our wall, and due to this structure, what structure, due to this irregular structure, there is a this is the what this is uh, radiation, and this is shading. Okay, that means if we irregular our wall, the radiate this, and this much is shaded. Okay, that means by roughly textured our wall, we can get some shading from direct radiation. Okay, the radiation absorbed such an, okay, then this is one way. Okay, and another way of shading is by using any concrete roof or anything in by using any roof uh, above our building roof. Okay, or by using any shading above our building roof. If we use concrete shade, okay, concrete roof above our building roof, then what happened, it protects, that direct sun radiation, but it also block the convection transfer or transmitted or return back thermal from our building in the night time. Okay, that means it protect from sun radiation. Okay, this is sun. Okay, but it also block the thermal radiate in the night time from our building. Okay, it prevent that. Okay, and if we use one what movable, okay, if we use movable, or if we use a uh, plant shading or deciduous plant of shading, here we can stop radiation or minimize radiation. Okay, here one part of the radiation going through, but rest part of the radiation is blocked. Okay, and it also prevent didn't or didn't prevent of our building emission in night time, because it is the plant, and there is there is gap on the shading. Okay, that means in deciduous plant setting, the radiation blocked, but the emission of heat in the night time from our building roof or wall is allowed. Okay, and due to the evaporation of the water in plant leaves, there is an evaporation process happened. uh, for that evaporation process, the the climate or the environment around the plant is lot more cooler than the around uh, of our building. Okay, due to that evaporation. Okay, so we can reduce our uh, what reduce our heat outside of our building or roof, outside of our roof, very muchly. Okay, and another way is we use a clay. We use a clay pot. Okay, we use clay pot, and use clay pot and cover that clay pot in in our roof or concrete roof. Cover that clay pot. That clay pot provide insulation from radiation, and also uh, didn't block our building radiation in the night time, because there is gap between the clay pots. Okay, the clay pots means ଯେଉଁ ମାଟିର ଧର କଳସ କିମ୍ବା ପାତ୍ର, ଯଦି ମାଟିର ଯେଉଁ ତାଟିଆ ଟାଇପ୍ର ହେଇଥାଏ କିମ୍ବା ବେଲାମେଳା ଟାଇପ୍ର ହେଇଥାଏ, ଯେଉଁ ମାଟିର ବାସନ ଆସେ, ସେଗୁଡ଼ାକୁ ସିଏ ସବୁ ଆମ ଛାତରେ କଭର୍ କରିଦିଆଯିବ। କରିଦେଲା ପରେ କ'ଣ ହେବ ନା, ସିଏ କ୍ଲେ ପଟ୍ ଆମେ ଜାଣିଛେ ଯେ କେମିତି ସୁରେଇର ପାଣି ରଖିଲେ ଥଣ୍ଡା ପାଣି ରହେ ଖରାଦିନେ, କାହିଁକି ନା ସିଏ ଇନ୍ସୁଲେଟର୍ ଟାଇପ୍ର କାମ କରେ। ଆଉ ସେଥିପାଇଁ ଛାତରେ ବି ରଖିଲେ ସିଏ ବି ଇନ୍ସୁଲେଟର୍ ଟାଇପ୍ର କାମ କରିବ। ଆଉ ସୋଲାର୍ ରେଡ଼ିଏସନ୍କୁ ବ୍ଲକ୍ କରିବ, କିନ୍ତୁ ଆମର ଏମିସନ୍କୁ ଥର୍ମାଲ୍ ଏମିସନ୍ ଇନ୍ ନାଇଟ୍ ଟାଇମ୍ ଫ୍ରମ୍ ଆୱାର ବିଲ୍ଡିଂ can be passed through that earth pot air insulation. Okay, but this is not a practical, or this is not a suitable practical technology, because this pot is very delicate, and we cannot maintain the or take care our roof due to the delication of the earth pot. Okay, so if we use a movable what if we use a removable or movable canvas cover. Okay, this is the canvas cover. If we use a movable or removable canvas cover, and this canvas cover painted white outside of this canvas. Okay, this canvas outside of this canvas painted white, because white color didn't absorb thermal energy from sun. And this due to this this is moving canvas, this canvas covered our what roof in daytime, and protect from direct radiation from sun. And also we can remove that canvas in night time and allow our uh, building to radiate the thermal energy to the sky and cool down faster. Okay, this is the suitable method used for passive. This method using canvas and the decidual plant. Previously we saw that the decidual this decidual technique is suitable for what passive shading of building. Okay, thank you.